All right, we are going to continue our study in truth tables and logic. We are going to talk about a specific type of statement called the conditional today. So let's start off by talking about what a conditional statement is. All right, so a conditional statement is a compound statement that uses the connective if, ... then, or anything equivalent to that. Okay, so if any sort of if-then statement, we've talked about if-then being a connective, if-then making it a compound type statement. In particular, the type of compound statement is a conditional statement. Okay, so for example, if it rains, then I carry my umbrella. Okay, so there are two statements connected by the connective if and then. It doesn't necessarily have to use the if and the then. It could be any compound statement that equivalently says the same thing. So you could, if you forgot then, if it rains, I'll carry my umbrella. That would still be considered a conditional statement. If the check doesn't arrive today, I will call to find out why. So there's an example where the then is not there, but it is still a conditional statement. If the first statement happens, the second statement will then happen. Right? If the check doesn't arrive today, I will call to find out why. All right, so let's talk about how we write this in notation that we have been using in this unit. So we typically will write the conditional using an arrow. So if P, then Q would be written with P and then an arrow to Q. So you can read this as if P, then Q. A lot of the times we will read this as P implies Q. Right, that's what it's saying. If P is a true statement, it implies that Q is going to happen, right? In terms of terminology, P would be what we call the antecedent, and Q would be what we call the consequent. Right? Antecedent, the thing that comes before, consequent, or you can think of it as consequences, right? Things that happen as a result of an action. So P is the antecedent, Q is the consequent. All right, let's take a look at an example here. If you eat wheat crunchies, then you'll be full of energy. Now, there are 4 different possibilities that could actually happen, right? So depending on whether or not the first statement is true, depending on whether or not the second statement is true. So let's take a look at each of these possibilities one at a time. So the first possibility, did you eat wheat crunchies? Yes. Okay, so according to the statement, if you eat wheat crunchies, will you be full of energy? Yes. So if P is true, Q is true. Okay, well, according to the statement, this would be a true statement. All right, second possibility. Did you eat wheat crunchies? Yes. Are you full of energy? No. Well, this statement that was given to us, if you eat wheat crunchies, then you'll be full of energy, would contradict this. So if P is true and Q is false, this is going to be a false statement. It's contradicting the statement that was given. Okay, third possibility. Did you eat wheat crunchies? No. Are you full of energy? Yes. Does that contradict the statement that was given to us? This one's a little bit trickier, but think of it this way. Did you eat wheat crunchies? No. Can you be full of energy from something else? Yes, that's totally plausible. Does that contradict the fact that if you eat wheat crunchies, you'll be full of energy? It didn't say anything about if the only thing you can eat is wheat crunchies in order to be full of energy, right? So this is true. All right, the last one. Did you eat wheat crunchies? No. Are you full of energy? No. Does that contradict our conditional statement here? If you eat wheat crunchies, you'll be full of energy. Well, did I eat wheat crunchies? No. Am I full of energy? No. Well, then this does not contradict that conditional statement that we were given. So we would say this is true. Okay, so based on this, we have actually come up with our truth table for the conditional. Right? We came up with truth tables for when we had P and Q, when we had P or Q, when we had negation of P or negation of Q. Right? We could come up with those truth tables. Now we can come up with the truth table for the conditional. So we looked at all four possibilities. The only case in which the conditional is false is if P is true and Q is false. So we'll go ahead and fill out this truth table. So just like we filled out the truth table before for the and the or statements, we have to write out all the possibilities. So true, 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 false, false, true, false, false. And then for the conditional, P implies Q. We said the first one is true. The only one that's false is this second one here. If P is true and Q is false, this is false. But for the other two, these are both going to be true. Okay, so the conditional is a little bit harder to grasp than the and the or statements. Right? It's kind of easy to think about, okay, it's only true if both are true. For the or statements, at least one of them is true. For the conditional, it might be easier to think about it as in which instant is it false. It's false if P is true, Q is false, then it's false. Otherwise, in all other scenarios, it is true. All right, take a look at example 1. Suppose you get a 61 on the test and you pass the course. Find the truth value of the following statement. If you get a 70 or higher on the test, then you pass the course. Okay. Rather than thinking about this in terms of the actual words themselves, we're going to break it down into the first statement, is that true or false? The second statement, is that true or false? And then based on our truth table, is that entire conditional statement true or false? Okay, the first statement, you get a 70 or higher on the test. Is that true or false? Well, it says you got a 61 on the test, so the statement that you got a 70 or higher on the test is false. Okay? You passed the course. Is that true or false? Well, according to the statement, it says that we said we were supposed to suppose that you passed the course, so that is true. So what we have right now is a false statement followed by a true statement. This is going to be true. All right, let's go on to example 2. Find the truth value of each of the following statements. If the earth is shaped like a cube, then elephants are smaller than mice. Okay, I know these are a little bit ridiculous. Hopefully it makes it a little bit more fun. But let's think about each statement on its own. So if the earth is shaped like a cube, is that statement true? The earth is shaped like a cube. No, that is false. Okay. Then elephants are smaller than mice. Are elephants smaller than mice? No, that's also false. Okay, so we have P is false, Q is false. So according to the truth table, the last line, this statement is true. Now it seems a little bit ridiculous because of the statements that are there. I know. But what it's saying is if the earth is shaped like a cube, which it isn't, then elephants are smaller than mice, which they're not. So that is a true statement as a conditional statement. All right, the second one. If the earth is shaped like a cube, then George Washington was the first president of the United States. Okay, so the first statement, earth is shaped like a cube, we already said before it was false. The second statement, George Washington was the first president of the United States, that is true. Okay, so P is false, Q is true. So according to the truth table for the conditional, this statement is true. Again, this is a little bit strange, right? But remember, this is sort of like if you think back to the wheat crunchies, right? Just because you didn't eat them doesn't mean that you can't be full of energy. So that's the statement that's here, right? So if the Earth is shaped like a cube, then George Washington was the first president of the United States. The reason why these statements are so odd is really so that we kind of come away from this. I mean, it is a little bit of fun, but also because this kind of takes away you trying to figure out, oh, is that true? Is that false? If we put it together, does that make that true or false? I want you to think about this in components, and then from the components, decide if it's true or false based on the truth table, and not by trying to reason out the entire statement as a whole. Okay? All right, so 3 special characteristics of conditional statements. So P implies Q, or if P then Q, is false only when the antecedent P is true and the consequent Q is false. Okay, that's the only case in which it is false. I know for the and for the or statements, we were talking about how to think about when it's going to be true, when is it going to be false. So for and, both have to be true. For or, only at least one has to be true. So now for the conditional, I want you to think this is only going to be false if P is true and Q is false. Okay, so if the antecedent P is false, then P implies Q is automatically true. Okay, if the antecedent P is false, then P implies Q is automatically true. All right, if the consequent Q is true, then P implies Q is automatically true. Okay, so this really we've already kind of written down in the truth table, but in case this is helpful for those of you who like to have it kind of written out, when is the conditional statement going to be false? When is it automatically going to be true? All right, given that P, Q, and R are all false, find the truth value of the statement. So with these, just like we kind of worked through these before, we're going to go ahead and write down the truth value of each part, and then use the truth tables to try to break it down even more and simplify it down more. So we're told that everything is false. P, Q, and R are all false. So I'm going to replace those and say false implies not false in the first one. In the second one, we have not false implies false. Now, we know that the opposite of being false is true. All right, so false implies true in parentheses, and then true implies false in parentheses. Now we'll take care of each parentheses on its own. So according to the truth table, we know that false implies true is true. True implies false is false. So we have true implies false, and we know that that is the one case in which the conditional is going to be false. So your answer for this entire statement, the truth value is going to be false. Okay, let's do an example where we, instead of doing it this way, we are going to construct a truth table and come up with all the different possibilities of whether or not the statement that we're given is going to be true or false, writing out all 4 rows. All right, so we have not P implies not Q, and not, parentheses, P or not Q. Okay, so again, start with P and Q. Okay, and then we're going to write down all 4 possibilities. And remember, as we kind of work through this truth table, at the top, we want to sort of build up until we get to that final column that will be the original statement that we were given. All right, and we know for not P, this is going to be just the opposite of P. So this is false, false, true, true. All right, now let's go to not Q. That's going to be the opposite of Q. So false, true, false, true. All right, next we're going to take that first parentheses, that not P implies not Q, now that we have both of those. So remember, the one case in which this is going to be false is if the first statement is true and the second statement is false. That looks like that's going to be the third line here. All right, so this is true, true, and then in this one, not P is true, not Q is false, so this is false. And both are true, so that's true. All right, now let's take the second parentheses, P or not Q. So remember which two columns you're looking at, the P column, the not Q column. Remember that for or, at least one of them has to be true in order for it to be true. All right, so that means we have true, true, this one is false, and this one is true. Okay, now remember that second parentheses has a negation in front of it. So the negation of the column before, just the opposite, is going to be false, false, true, false. And now we're going to combine this column that we just did with the not P implies not Q column. And we have an and connecting them. So that means that both have to be true in order for it to be true. So the first one we've got here is true and false, so that's false. Next one, true, false, that's false. False, true, that's false. And true, false, that is false. So no matter what combination of P and Q you have for this particular statement, it is going to be false. All right, let's do another example. Let's start off by doing P and Q just like we have been doing before. So both true, true, false, false, true, false, false. All right, for the next column, P implies Q. That is going to be just our regular conditional. So remember the one case is when it's true implies false, is false, everything else is true, right? So true, false, true, true. All right, look at the second parentheses there. We have not P or Q. So let's start by writing down what not P is. So that's the negation of P. So false, false, true, true. Okay, next we have not P or Q. Let's combine those two columns. We find the not P column, the Q column. As long as at least one of those is true, then this statement is going to be true. So true, false, true, and true. All right, last column. Last column combines everything, right? So now we're looking at P implies Q. That's the third column. And the column that we just filled out, not P or Q. Remember, the only case in which the conditional is going to be false is if the first statement is true, the second statement is false. Okay, so we have true, true, so that's true. False, false, that's true. True, true is true. True, true is true. So in this particular example, it looks like that no matter what combination of P and Q you have, your statement at the end is going to be true no matter what. All right, writing a conditional as an or statement. So another way to write P implies Q is to use the statement not P or Q. That is equivalent to saying if P happens, then Q happens is the same as either not P or Q. Okay, so let's take a look at some statements and we'll try to rewrite them as an or statement instead of using the if ... then statement. Okay, so write the following statement without using if then. If this is your first time, we're glad you're here. Okay, so let's just write down what the statements are. So this is your first time, that's the antecedent P. And then we're glad you're here, that's your consequent Q. Okay, so P implies Q. Now remember, what we just wrote down was that the equivalent of this is not P or Q. Okay, so now let's just write that. So not P would be this is not your first time. And Q, we're glad you're here. So this isn't your first time, or we're glad you're here. Okay, now the negation of P implies Q. Another way to write the negation of this is P and not Q. Okay, P and not Q. Okay, so we'll again do some examples where we can actually see how this works. So write the negation of each statement. So if you go to the left, I'll go to the right. Okay, so again, we're going to break it down and say, okay, P is you go to the left, Q is I'll go to the right, so P implies Q. And we said this is the same, the negation is the same as writing P and not Q. Okay, so if we're going to write this out, you go to the left and I won't go to the right. Right? You go to the left and I won't go to the right. All right, the second one, it must be alive if it is breathing. Okay, this one's a little bit trickier because the if and then part, if you're kind of looking for the antecedent and consequent, has been switched up a little bit. So it looks like we have it is breathing, right? If it is breathing, that's your antecedent. Then it must be alive, right? So just make sure that you pay close attention to where the if statement is, where the then statement is. Not necessarily will be written as if ... then ... Okay. So the negation of this is going to be P and not Q. So now we can write out it is breathing and it is not alive. Okay, remember this is the negation. It's not an equivalent statement of what we're writing. It's the equivalent of the negation, right? So normally you would say, if it is breathing, it must be alive. So the opposite of that, the negation of that is it is breathing and it is not alive, right? That's the negation. All right, that is all we have for today on the conditional. We will continue to do more on the conditional and more examples in the next lesson.